So this is Ellie Sellers. I am going to talk about our program that we made this semester, Funny Weekend. This program we made to be kind of a learning program for younger children. The setting is a weekend and there's several activities that take place. At each scene or activity, the user has the opportunity to do either a word activity or a math activity, depending on which location or scene that they choose. Each scene will request something of the user and will do some figuring or calculation or matching, and the user will be presented with a message saying, yes, your answer was correct, or no, it wasn't. So that's kind of a rough overview of our game. To put this game together, we had to implement a bunch of things that we learned in our class this semester. A few of those I'm going to talk about. The first is a static class variable versus a non-static instance variable. So I'm here in my calculation control class, and this calculation control class uses several static class variables. For example, this one, calculate average, is a static variable that creates a formula that kind of runs through something and it makes it work. It's kind of a larger level. And then this particular function is called by a more specific view, and then it creates an instance of this particular variable. So an example of that is over here in view 13. We call the calculate average function and create an instance of it. The function is kind of a larger, more general type of variable, and then when an instance of it is created, then it's applied to this very specific view or section of the code. So that's kind of an example of that. They're very valuable because then you don't have to double code a bunch of stuff. The next thing is arrays, array lists, and enums. Arrays are a fixed length, and all of the variables in the array has to be the same type. So for example, we have an array here. This array is declared as being an int, so all of the spots have to be filled with something that is an integer. An array list can differ in length, so it could be 3 one time, it could be 6, it can go back and forth, and it will allow different types. So it will allow an int and a double and a string, all in the same array. So in some ways that's very nice to use. For ours, we just needed them to all be the same, so we chose to use an array. The third type of list, I suppose, is an enum. An enum is a fixed length, just like an array, and they all have to be the same type, just like an array, but it's more set in stone. So for an array, you can change these numbers throughout the program, but an enum, they have to stay the same. They can't be removed or changed at all. So for example, our views, we wanted to have a very specific number of them, and we didn't want them to change at all. So that would be a good example of an enum. The next thing I wanted to talk about is a for statement. Back at this calculate average function, we have this array of different scores that a person could get on a test. The test is 100 points, so none of these scores should be less than 0 or greater than 100. And we declared that in our test matrix at the beginning of the semester and decided that that's the way we wanted to do it. What we have here is a for statement that requires an index, and as it goes through this little loop here, it checks to see if each of these spots individually are less than 0 or greater than 100. And if either one of these is true, then it will throw an exception or an error for the user. And then after that checks out, we have another for statement down here that uses another index to add each of the numbers together and then create an average by dividing it by the length of the array. So these are very valuable because it systematically goes through each object in an array or in any type of list. And so it makes it so you don't have to go through and find each individual spot. It'll just automatically go through it. And this is great, especially for arrays, because they're all nicely packaged all together already, and it wouldn't do us any good if we had no real way of accessing that information that's stored all together. So for statements are great. Okay, the next thing I wanted to talk about is exceptions. Exceptions are important because you want to know if something goes wrong, where it happened, and you want to be able to let the user know, hey, something's wrong, either you entered an invalid type or the answer's wrong or whatever. Then it will throw an exception or an error to say, red flag, stop, turn back, do something different. So right here, these are all statements that say, okay, this is going to throw an error. Over here in our main menu view, we have an example of where an error is caught. So for example, we want this to happen up here, and then if something goes wrong, then we want it to catch an error and say, okay, something went wrong down the line, catch an error and display it to the user. So it's important to both throw and catch an error so that the message gets delivered completely and there's no confusion on the user side. The next thing is a character stream versus a byte stream class. So a byte stream class is a series of, say, numbers that represent each character. So L would have 8 different numbers, and then O would have 8 different numbers, and then C would have 8. So they're like pulses of numbers that say, okay, this is what it's spelling out. And that doesn't always have as much detail as a character stream class. So sometimes using a byte stream class is acceptable, but it's better to use a character stream class because you can get more detailed information. And so it would pass an L and then an O and then a C instead of a bunch of little numbers. And it doesn't go as long because there's not as much information to process. But you can get more detailed because you have the characters instead of a bunch of numbers. It's important, especially when you're writing to a file, when you're saving something, reading or writing to a file, to use a character class because there's so much information stored in a file that it would be easy to get that information confused or lost if it was just in a byte format. What we have here is where our file is written here, and then it's saved, and then it'll throw an error or whatever if something doesn't work. So we used a character stream to make this happen because that's the easiest and most efficient way to get that job done. Okay, now the fun part. I'm going to run my game for you and show you just kind of what works and how it's all put together. So we started out with this welcome view. It kind of describes the game, sets up what happens and what the user can do. So we start out, and I'll go ahead and enter my name. And here it gives a welcome message using the user's name, so it's collecting information from the user. And then we have our main menu, which gives the user some basic options to start. I'm going to go ahead and push a new game, and notice that capitalization doesn't matter. It'll accept either lowercase or capital letters. So one of the locations that I worked on was 13 right here, Friday Math. So I'm going to go ahead and enter that in. Friday Math, this is the one where we're collecting the scores for the different tests, and these are the same numbers that are in the previous array that was displayed. So I know that the average here is 92. It's rounding to the nearest whole number, excluding decimals. So I'm going to enter the average, but I'm going to enter a wrong answer so that you can see what happens there. So 64 is obviously not the right answer, but I'm going to enter it so you can see what happens. So it throws an error. It says this is not the right average, and then it gives the formula and requests that the user try again. It displays the scene again just so the user can be reminded of what the numbers are and what they need to do. So I'm going to enter the correct answer this time, and I get a corresponding message. This is the right average. And then I am brought back to the locations menu where I can choose a new scene. So for the fun of it, let's go ahead and do another one. Number 23 here, Saturday Math. So I'll go ahead and enter that in. This one is requiring an average, or a total. So you add the three numbers together and enter the correct number. So I'm going to enter a wrong number on this one as well, and then I'll enter the right answer so you can see what happens. So 20, and it says here's the formula, that's not right, try again. So the correct answer is 1678, and so I get a corresponding message, and it brings me back to the locations menu. And then if I want to quit the game, then it'll bring me back out to the main menu, and the user has some more options from there. So that's kind of our game, and it was really fun to put it together. Ran through some bugs along the way, but I learned a lot, and it really helped me to get a better understanding of Java and how the different pieces fit together, the MVC model, different classes, functions, and I really just learned a lot about Java, and I feel like I have a better understanding of how it works and how it all fits into everything else that I've learned so far. So thank you very much for watching, and that's all that I have. So